Good morning, everyone. This is, of course, you've seen me here a few times before. I wanted to do, I'm getting an echo. Yeah, I wanted to, so we have this QART visual or cart visualizer, and I really wanted to do a pop-up series where we show you, historically, even I've alluded to using Netron, but this thing is like super powerful. So I really wanted to do like a pop-up series where we'll just go through. So today we'll really just dig into how to install and get everything up and running. And then just from the initial visualization point, you'll be able to see some benefits. And then the next two videos will really dive deep into some stuff that really separates this cart visualizer from anything else that's out there, actually. So let me go ahead and share my screen, and let me do this the right way this time. Okay, so what is the cart visualizer? And I'll just drop this link, how you can get to the documents pretty quick. Or they'll drop this link. So cart visualizer, if you're familiar with Netron, one thing Netron is good for is we can look at the internals of our model. And this is what the cart visualizer is going to do, but it's going to streamline this process. So just from here, you can see this almost looks exactly like Netron, but once we grab an actual model from Hugging Face, you'll see the differentiation. We'll start getting into some performance and analytics where we can do some op tracing. We can get some profile metrics, all in a very nice, in a nice GUI. So let's go ahead and get started because, like I said, I can get long-winded, and we just want to get this from scratch. So first thing I'm going to do, as I always preach, is we need to be inside of a virtual environment. So I already have some here, but I really want people to get into practice for very beginners of just creating your own virtual environment for everything. So because we will be using the QAIRT SDK for the next few videos, video 2 or 3, then we will need Python 3.10. So just real quickly, we can say Py v 3.310. Let's do VNV, and then let's just call this, I already have some called cart. We'll call this cart 2.0. And then this is this easy to just go ahead and set up the virtual environment. Please get into practice of doing this, because if not, you will be things can get nasty. Then we'll go ahead and invoke this, and forgive me because I have been in Linux land for the past couple of months, so I need to remember Windows commands. So now this quick, we're in our virtual environment. Now we're ready to get started. So in the docs, we see this is very easy to set up. And I have a bad habit of just scrolling documents to get to what I want. Here we go, right here. So we'll just go ahead, and this is quick. And then while that's doing that, let's go ahead and just open up Hugging Face. Get on Hugging Face right now because we want to go ahead and grab our model. This will be done by the time we come back. Let's search for a model because this is what we want to do. Go to models. Let's grab an Onyx model. Although the cart visualizer can take PyTorch, can take TF Lite. We're just going to go Onyx because eventually we want to get to a point where we show our conversion from Onyx to DLC, and then we'll be able to do a side-by-side of exactly what optimizations were done that are going to get delegated to Hexagon, which is our NPU. So let's see. I know there are a lot of people that are really interested in Gemma. So let's just go to the Onyx community to get rid of some of this noise. And I'm looking for Gemma which I already have on my computer. I don't know why I'm doing it this way. Okay, you know what? Gemma, let's do the group query attention version, instruction tune. This isn't going to be, this is safe tensors. Okay, let me just do it the way I know. Either way, we're going to go to Onyx. Let's grab a Gemma model, instruction tune. I want the group query attention version. That's what I'm looking for. Because then that'll get us in. Oh, here we go. Okay, so Gemma 3, 1B, group query attention. I'm just going to grab, usually, really, we would grab all of these because all of this holds some important information. We're going to start with the floating point 16 because the device that I use, this is already quantized, which is beautiful. We don't have to fight with quantization. The community does it for us. So we're going to download this. At this point, this is done. So QAIRT visualizer finished before we even got our model. So now let's start here, QAIRT visualizer, and see what kind of options we have. Always look at help. Okay, so we see we can pass a model, we can pass a string, which just gives us a path of what we want to visualizer. We can see the version, but even more importantly, all we have to do, visualizer, because I haven't had any coffee yet. All we have to really do is do this. And now you see, now we're inside of our QAIRT visualizer. So, and I already had Llama up. This is, of course, this is drag and drop. So let's go to my downloads and it just finished. Perfect. So we can drag and drop that here. And this, just off the bat, you can see something that is very nice about this QAIRT visualizer. Yeah, actually, I'll do a side-by-side with Netron. Actually, we can show a Netron kind of version. But instead of getting slammed with all of these different nodes, so this is what Netron gives you. This is another thing that's nice too. As soon as you open up, you get slammed with this huge graph. And you're like, man, what is going on here? How do I navigate this? And this may be useful in certain aspects, but we don't really need this. We don't really care about any of the stuff that we don't care about ultimately. So what I'll usually do is come over here first, and I want to understand what my input IDs, or let's start here. Model properties. So we have our input IDs. We know we need that. This is going to be our tokenized IDs, our attention mask, position ID, and then our past KV cache, our past KV, which will also give us our present. So this is real nice. We see what's going on. It's easy to look at. Now we can come over here and uncollapse this. And now we can get even more details. Okay, so now I see that my position IDs are coming into here. And that's another nice thing about this, is that we can see exactly what is being used. And I don't want to zoom out too much, but we can see exactly what's being used. So we see our input IDs are coming into this graph called position IDs reformat. We're getting some shapes, we're unsqueezing some dimensions, we're reshaping some things, and then we see how this gets propagated everywhere. So this highlighting is very nice when you're trying to understand how all of these things are connected. And the fact that this is collapsible makes it even nicer, honestly. And then again, we have our attention mask. We can see what comes into that. We can see the input is actually our attention mask. We can see that from here. And then also for this shape, we get this from attention mask, which we see over here. We can see all of our properties, which these everybody should be familiar with because this is the same kind of flow that is within Netron. So let's go ahead and collapse this again, because now I want to see, okay, so now we have this. And now allow yourself to go down the rabbit holes, because I went down a rabbit hole also of like, okay, shouldn't my input IDs somehow be in this embedded tokens? Shouldn't we see a branch going from here? Because our token IDs are going to basically use this to grab the embedding vector. I didn't really get a clear answer. But either way, this is our basically our embedding matrix. We see our vocabulary size by our embedding dimension, and then some scalar. Again, rabbit holes, go down, learn as much as you can. Really do. This is what's the beauty of this is it allows you to really do surgery on these graphs and understand what's really going on. So we do know that our input embedding, our input IDs are going to go through our embedding matrix, and then it's going to basically be a lookup table that gets fed into our first layer. And we see for this guy, we have, does it start at 0? Yeah. So we have 26 layers. So let's just open one of these layers. And that's another beautiful thing about this is we know for the most part that unless you're doing some researchy type stuff, we know all of these layers are going to be pretty much the same. So I don't really need to have all of this expanded to know what's going on. So let's just look into one of our layers, and we see now we have a simplified layer norm. And I'm going to kind of do some foreshadowing. This, when we get to trying to get this to run on hexagon, has to go. So we'll be replacing this. Another thing we'll be doing is that, let me go here because I want to get to here faster, input IDs. Okay, no. Okay, here it is. Another thing that we'll have to do is all of these dynamic shapes, they're out of here. These are some of the changes that we need to make in order to get this to compile to hexagon. But again, simplified layer norm is feeding into here. We can open up our attention, and then we see that we have some matrix multiplication. We're normalizing our query matrix, our key matrix, rotary embedding. And we can also track and see, okay, what's being fed into our rotary embedding? Well, what's coming in? What's the input from here? It's going to ultimately be well, let's see. Because I was expecting it to be, I was expecting it to be like the position IDs, but it comes actually from this graph, which ultimately gets the position IDs, because that's how we're going to use to get the positional embedding. Then all of this is fed into our group query attention. And again, we can see exactly what's going into our group query attention. We can also see everything here as well. So we can see we're getting the query from our rotary embedding on the query matrix. The key matrix, we're getting it from the value matrix. We're also getting our past keys values. And if you want a deeper dive into this, go look at that DeepSeek blog where we really dive deep into, what all of these means. And it's the same. What you learn from looking at that blog applies not only to DeepSeek, but also to Gemma and everything, so on and so forth. Our sequence lengths, but we see everything here. We go through our group query attention, and we go through another layer normalization. Then we have these skip layers. So this is bringing the gradients all the way through to the second layer, which is basically saying, hey, this is what I knew before. And then we want to keep some kind of history as we go into the next layer so we can see all of that. Again, go down the rabbit holes, ask yourself questions, ask your favorite LLM to, explain this stuff, and just do surgery on these graphs. And then we go all the way to here, and then we get our output. So from here, we get our output. And let's collapse this again. And yeah. So here, and then we ultimately will get our logis. That's what is going to be returned after we pass in our input IDs. This is going to be for our prefill and our decode phase. So this is the visualization part. And you can already see some benefits just with collapsing. And if you have any questions, the team that actually developed this, they are in the audience. So, feel free, anything you would like to see, feel free to, ask questions and everything. Okay, so now what do we want to do? Let's go ahead and hit install notebook, because there's another way of doing this visualization. Go into our notebook. This one actually takes longer than actually installing the QAIRT visualizer. Almost there. Okay, so now let's just open up our notebook. Notebook. And it opened it up over here. Okay, let's just open up this. It's safe. So of course, path library. So now you can also look at this from here. Oh, and you know what? I'm gonna have to go into another virtual environment. We didn't go through the QAIRT setup, but to do this converted, you will have to go through some setup steps for QAIRT SDK. It's very straightforward. I went through the documents again last night, and it's basically just step by step. But what we can see just from here, yeah, I'm not in the kernel. Let's see. We need to do we want to do this? No, I don't. I'm going to go into the one that deactivate this. And this is the beauty of these, what is it called? This one of PS1. And now let's shut this down. Leave that. Let's come back here in this environment. Okay. So we also have a way of doing this via Jupyter Notebook. We set clear all outputs here. Okay, there we go. No, there we don't go. Okay. We'll just look at the visualizer for now. Maybe when I shut the computer down, some of my paths may not have been persistent, but okay. So now from here, within the notebook, we can go here. And we'll go through setting up the actual, because actually converting the model to DLC format, that's going to be in one of the other videos. I was just playing with it last night. Let's get this. We can get display options. And these are all in the docs, which once you're in the GUI, a real quick and easy way to get to the docs is here. And then it will pull it up. It pulled it up in another screen. But then you'll get the starting point, which is real nice. You don't have to go to Google and search every single time. Let's go here. Let's grab these guys. And this is directly out of the docs, actually. Display options. So if we want to use the same workspace, then it will display it within. And then I have model directory. Okay, is this true? Yes. We're going to look at Gemma. That's the one we just did. We're not going to do this. We'll save this for another video. But what this converted model does is it converts it to the DLC format, and then we'll be able to do a side-by-side comparison and see what optimizations, what operation fusions, and all types of things that actually we do on our end to optimize for Hexagon. Okay, so now let's say, oh, this is going to be live. Let's see if this works, because I actually didn't test this one. And then we want to get out of a path live. Okay, look at that. And this was live because I actually didn't test this, so that was my anxiety went up a little bit waiting for this. But you can get it right directly in a notebook, which is the important thing. Because, you know, anybody in AI loves their notebooks. The people that are like hardcore, super down in assembly language hate notebooks. I don't understand it. But yeah, so this does take a little bit long. I mean, the GUI is super nice. So let's just, while that's loading, another thing that we can do is say you're looking for, let's see if this, oh, yeah. So you can actually search for, this is what I should have used before when I was looking for this. You can search for it and it will go directly to the node. So say you're doing some research and you've added some exotic new node and you're like, where is that at in the graph? Oh, I added this transpose G14 classified. You can go directly to that and it will show you where it's at and you can see how it's all wired in. Another thing, so we can go ahead and collapse everything, get back to normal quick. We can expand everything and just see the full entirety, the full beast monstrosity of this model. Collapse it again. Then we can go into a Netron type of format. So if if you're like, oh, I love my Netron, I'm not trying to change, kind of like blue boxes and text messages. You have your Netron version here. And then when you're ready to convert to something more advanced, as we get into start collapsing and getting into things, reset. And then it gives, you have your legends here. So this is real nice. Now let's go back to this notebook, which is still loading. We're going to get there eventually. We will get there. But you don't really need this because you can also do things like, say you just want, we're all in notebooks. So take a screenshot. If you want to embed something and then turn this into Markdown, paste that there, and now you have your report right there. But this is nice. And when I did the converted part last time, I did see something. We're just waiting. Okay, there we go. We're inching along. And here you go. You have the same exact thing here, but within your notebook itself, because we love our notebooks. And everything that we just kind of went through, you can search everything, input IDs, attention masks, do all of this searching. Everything that we did in the GUI, we can also do in the notebook, which is very nice. What else? So yeah, so what we are going to get to next is, so stay tuned. This is I really just wanted to get everybody up and running. You see how quick and easy that was, so that when we get into some deeper, cool stuff like op tracing and everything like that, everybody will be able to get quickly set up. Watch this. Oh man, I'm almost pushing 30 minutes now. Watch this 30-minute video, and then we're off to the races because we're going to really get into some cool stuff where we'll be converting these Onyx models to DLC, like I said, and then we can trace this. And as you select, what'll be cool about this is we'll look at this side by side and we'll say, okay, maybe this block got fused into something else. Well, we'll be able to click this in the Onyx graph and it will point exactly to, it will highlight what got fused in a side-by-side manner. So yeah, I think this is where we'll leave it at today. And then, yeah, stay tuned for the next video, because like I said, the ultimate goal will be what a ton of people have asked. How do we go from here to inspecting the models, to performance optimizations, to getting things running directly on Hexagon? That's like the holy grail, and that will unlock a lot of people. So that's what we're trying to get to at this point, easily, using tools that people are familiar with. For example, Netron, now QAIRT visualizer, which I don't think anybody probably is going to use Netron after looking at this. But either way, let me go and see what kind of questions we may have. Oh, Netron is OG, but if you also look at the videos, they're OG enough to where all of the videos, the recent videos of Netron are like 4 years ago. So maybe they'll step their game up. I always like a little friendly competition. But yeah, this card visualizing, this is just touching the surface of what we're going to be doing. But this is Netron, and even opening certain models, it's way faster in this card visualizer. So hold on, let me go on to Discord because I can't see anything else if there are any questions. And if there aren't any, let's see. then I guess if there aren't any, then we can wrap this up here. Yeah. And also feedback, any feedback that you have, any features that you may want to see, please either leave it on YouTube comments or there's a feedback part on the actual docs. Either way, let's go ahead and wrap this up. Um, have a good day.